In this Raspberry Pi Pico small car lesson, we are going to learn how to put together the servo motor, the ultrasonic sensor, and controlling the motors to drive the car and avoid obstacles. Welcome to Raspberry Pi Pico small car course by Robojax. My name is Ahmed Shamshiri and I will be your instructor for this course. This course is based on Sunfounder's Raspberry Pi Pico 4-wheel drive car kit. Beside this 10-lesson course, the kit has full documentations, step-by-step instructions, wiring diagrams, Python codes, and example projects available for download. The car can be controlled using mobile app for mobile or tablet, where you can control the car fully forward, backward, turn right, turn left, and also you can turn on and off the light. You can set the power of the motors. You can see the speed in meter per second. You can see the radar obstacle avoidance data where the obstacle is. Also, you can see the line tracking or a halo deep sensor data. It can track a line or follow the line. It has cliff detector and it can follow your hand and it can avoid obstacle and drive. The kit is available for purchase on Sunfounder and major online stores. The link to purchase the kit is below this video. Let's have a look at this obstacle avoidance feature of this Sunfounder smart car robot. We are using a servo motor to rotate our ultrasonic range sensor. So this will act as a radar and we will measure the distance of the obstacle between 0 to 180 degrees. And in between, we will find an empty path and the car will proceed in that direction. So it looks left, right, and if there is no obstacle, it will just go forward. But if there is an obstacle, it checks left and right, and whichever way it finds empty space, it proceeds. Now I'm running the code. I removed it so I can move it to any direction easily, so you can see it on the screen. Let me run the code. Now let's test the Sonar. Under the test, inside the test folder, click on Sonar, and here is the code. We're importing this from this file, creating an object as car. We call it car, and this is a function that does the task. Under the try, we use this code. The rest is exactly the same. So here, while true, as long as it's true forever, it measures the distance. So we say distance car Sonar get distance. So this is getting the distance for us here, and this is just printing it, formatting it as a string on the screen. With 1 second delay, we can read the distance. And if you want to do something with the range, just get this distance variable and do mathematical calculation or if condition, whatever you want, you can do with this. Let me run the code and you will see that this will print here with the word distance with a colon and then formatted with a string with this value here Now it's 37 centimeter, 37.2, now 22.55. And now let's point it to the ground. So we are getting here 11 centimeter. If I go down 6 centimeter, let's go to the ceiling. There is a light, and let's face it, point it towards the wall. 175. So now this is 200 centimeter. Now let's point it towards the wall. 173. Now I'm pointing it towards something else. This is now pointing towards the computer screen. See, I'm going to put this ruler here. So I'm going to put a box here. And that's exactly at 0. Let's put it around 19 so you can see 18.4. Let's go down so maybe I put it properly. Now it's 18 centimeters, this edge. So we are reading 17. Now 18.7, so that's at 19. Let's go closer at 10 centimeter, so 9.6. That's not bad. Because this is ultrasonic, so this is not that accurate. If you want very precise measurement, we need laser range finders. Let's have a look at this example of obstacle avoid. Now, if we go under the example and obstacle avoid, this is the page where it explains how it works. And the most important part is this algorithm as flowchart. Let's have a look at this flowchart. Now let's have a look at this flowchart. Start, we have a function called get radar status. So this get the status, and we check if it is finished. So scan finished, yes. So we follow in here. If scan is not finished, then detected obstacle and not in danger, it checks. If obstacle is detected, then we set the status string as danger, so this is a text, and then the car stops, and then we set the angle to 180, and we come back and we get the radar data. If the danger is not there, there is no danger, then again we go back to get the radar data. Now when the scan finishes, yes, then we set the status value to save. So save means safe actually, so they put save and danger, so it's safe. And after that we get the direction. Direction is doing a lot of work here, which I'm going to explain in here. From direction we get 3 string or 3 values, right, left or forward. Now if it is forward, then set the radar scan angle to 50, so the servo can scan. So the servo can scan only 50 degrees, not 180. And the car moves forward, and every few seconds it comes back and it does the whole thing. Now let's see what happens between left and right. If the direction says that on the left side it's empty, so after that servo turns right at 25 degrees and the car turns left. So it checks if when we say turn left, it turns left, and the servo turns right to make sure there is no obstacle, and the car turns left. And then we check if there is an obstacle. Yes, then the car will turn left again, and it will continue. If there is no obstacle, the car will stop, and all the angle and measurement will happen, and if there is nothing, it will go forward. It will come to this. Now when we check the direction, if it says turn right, then the servo turns left. When it was left, the servo was turning right. Everything that you see is the opposite. And here the car was turning left. When we go to the right, the car turns right, and the servo turns left again to check. And if there is an obstacle, yes, it turns more to the right, continues until there is nothing. If there is no obstacle, car stops, and the measurement will come back, and after short stop, it will continue. Now, get direction is something that we have to find out and see what happens. First, we convert radar data to a string, and then split the string with 0. So everywhere that we see 0, we will split it, and we leave the free space. And then we calculate the width of each path. A path narrow less than 4. So we get a string. Of radar data, and we split it with 0. So this will be one piece, and this will be another piece. This is another piece. And if we have less than 4 pieces of one, then it is very narrow. And if we have a lot of one, which means a lot of empty space, that is where it's valid for us. And the total we have is 16 pieces, 1. So then get the widest path position, and we will find out at what angle. And if the widest path is on the left, turn left. If it's on the middle, go forward. If it's on the right, go right. So these 3 values will be provided in this area. So we check if it is right, we turn right. And if it's left, we proceed with this algorithm. If it's forward, we proceed like that. Now, if we open this obstacle avoidance, this is the code where the car is being controlled when it sees an obstacle. So we are using the servo motor, we are using ultrasonic sensor to measure the distance, and we are controlling the motors of the wheels to move. So this is the reference that we have, the radar reference, 20 centimeter. And this is the radar step angle. We go with 10 degrees every move that we move our radar, our ultrasonic sensor. That's the forward speed 30%, and the turning speed with 50, and forward scan angle 50. First, we use the set radar scan angle. So this will set initial angle on the sensor, and it sets the state as danger immediately. Now this is a function called get direction. So this will get the direction. Let me explain the next one. That's the main, and that's done. When the code runs, the code will run the main. So here the main will run. It will run forever. First, it says global status. Status is a variable that is outside this. So global status, we are defining this variable to be accessible by other functions, other part of the code. And while true means run forever. And then we get radar scan, and then we get the radar data. The radar data will be, and we get the radar data, and that will be the distance. And in this line, we check if the instance of this radar data is an integer. So we check it. If it is integer, you see this portion f is up to here. then we get the data. If data is equal, set as 0 and the status is not danger. If it is not, then it prints danger. So this means not. It prints on the serial monitor the word danger, and then the status sets it back to danger and stops the car, and then sets the radar scan to 180 degrees. Now, if we set it to 180, it will be from 0 to 180. You can also set it minus 90 to 90 as well. Else, it says that save, so we are not in danger. When it's safe, then the call will proceed. Now, first we get the direction using the radar data that we have, the distance. It goes to get direction. This get direction is a function which will tell you which part of the which area, which direction is empty for the car to proceed. And here I've loaded the code, and let me show you. Right now it's everything is empty, there is no obstacle. And let me bring an obstacle here. I just brought an obstacle, a box, and it says turn left, and it goes forward. Again, turn left. The only way that it knows is turn left. And here the code that I've extracted is this portion where it says car radar scan, and we are storing the result in here. And this line is just printing it with this text so we can see in the shell screen. So let's click on view and shell, and now I press this run. It goes to the board. Because it's not on, we are just reading 0, 0, 0. Every 4 value that we read as an array, as a list, and then it will be printed one by one. So I'm just turning it on. Now we are reading 1, 1, 1 because there is no obstacle here. It's just pointing to the ceiling and there is no obstacle. Now, or let me put my hand here. When I put my hand, we will read 0. So we understood that 0 means obstacle and 1 means nothing, empty space, or just run. And we printed it, this line, and this is inside the obstacle avoid. And we get this data and we say if instance of this radar data is integer, so this will make it integer. From here to here the if will run, and here we check if the data is equal 0 and the status is not equal danger, because we are setting the status in here as danger and here the original code as danger. So if it is not, then we print danger and then we set the status to danger. Now if the status is 1, it will change, because if the data is equal 1, it will be empty space. Now this is the example 2 for the obstacle that I created. I've taken the code and I've full get direction function up to here, but in here I'm setting the status as save, and then I say get direction. I pass this data here as a list. I put square bracket around it. So this is sending it to that direction, and we get direction back and we print it. As you can see, it says left. There is no much data, it's not on. So this value, when it comes here to this function, this is getting the direction for us. As you see the status, it gets the direction. Then we check if the direction is left. Usually it's only about left, because this has been programmed to look for the left. And if it is left, then it prints this turn left, and again it checks the distance at a specific angle. Forward scan the value that is 20 centimeter divided by 2. So we get the distance, and then we wait and then move the car to the left, because the direction was left with this motor power. Now this while true means up to here it continuously moves the car to the left, and it moves the car and it checks if the status is equal 1. Now what is status equal 1? This is a function in here, get radar status. If the distance that we measure is greater than the distance, then return equal 1, which means it's more than 20 centimeters, otherwise it's 0. So if it is more than if it's equal 1, which means greater than 20 centimeters, then stop turning, because this was just turning the car. So this will stop turning and it will print this stop, and then set the angle for the forward angle, and then the car will proceed forward, because now we set the status to 1 and the car has been stopped. Now this now the loop will go back. Again we read the value, and because we have this not danger, and if the data is not equal danger, then and there is obstacle, then we do this. Otherwise, again we get the direction, and if there is nothing in front of us, we do not get left. Pay attention here, it comes right, and we will get forward because there is nothing in front of it, so it goes forward. If the obstacle is detected to the right, then this goes the opposite direction of the left, which was going for the left scan. This is going for the right scan. It checks the right and turns the motor to the right with this motor power, and this was turning motor to the left with motor power. Now for the right as well, we have true. We have while loop that continuously goes in the right direction until the distance on the path is greater than 20 centimeters. I mentioned 20 centimeters so many times. This is a 20 centimeter radar reference. We set it here, which goes in here. So that 20 centimeters is coming into effect from there. And as soon as the distance is over 20 centimeters, then we print this, we stop the car, and then we set the angle for forward scan, and this will turn back straight to measure the distance at 45 degrees for the forward. Otherwise, it goes, when there is an obstacle, it goes wider. This is an interesting code. You can play with this, maybe fine-tune it or make it better, but excellent project for learning. Here I've created all these obstacles. I don't know which way will it go, but hopefully when it goes here, it might turn to the right and goes there, and then finally finds a path somewhere there. But when it approaches there, it should turn back, and I don't know, maybe it finds a path here or that way, but let's see what it does. I'm putting it here so it starts from this point. Let's turn it on. So it hit that small obstacle, but if I put my hand, it should come this way. Hopefully, yes. I will guide it outside because we are under the table. And we came back to the same spot. Thank you for watching a Raspberry Pi Pico lesson from Robojax. Please don't forget to subscribe to my channel and thumb up the video. You can wait a few seconds. The next lesson will start automatically, or click on the link to proceed now.